My final is going to be on the Northridge earthquake of 1994. Excuse my voice. I had a cold and I lost my voice, so I sound a little bit raspy, but I'm going to try my best to make sure that I sound good throughout this video. First slide is about the different things that can trigger an earthquake, starting with plate tectonics, which is a scientific theory that was developed in the 20th century that the Earth's lithosphere is made of several large tectonic plates. Volcanic activity causes earthquakes when volcanoes have built up pressure within them and it changes the rocks that surround it, and that often results in breaking or moving, which results in earthquakes. Underground explosions also are a common thing that cause earthquakes because of the pressure waves that get sent from underground explosions, and they create stress imbalances that travel through the earth as seismic waves. Large rock collapses can cause minor earthquakes. This is because the collapses shift the rocks in the Earth's crust. And the last one is going to be about human activity, which include things like mining and fracking, wastewater injection, human-made reservoirs, dam building, and things of that sort. And this is something that often causes earthquakes because, of course, we're drilling into and messing with the Earth's crust. The earthquake was caused by a much less common type of earthquake. It was triggered by a blind thrust fault. This is a fault that lies completely underground and was completely undetectable. This was another reason that there was so much damage caused from this earthquake, because the people were so unaware of what was about to happen. There was little to no preparation. This slide is about the Richter scale. The Richter scale measures the intensity or magnitude of an earthquake. If you look here, you can see that this is represented through a 1, which is purple, all the way up to a 10, which is red. This was created by Charles F. Richter in 1935 at the California Institute of Technology, and this is still used today and very important to society in understanding earthquakes. The Northridge earthquake was a 6.7 magnitude earthquake. Looking at this map that I put on here, you can see on the bottom the Richter scale once again, and we can see red all the way to purple. Looking in the Northridge area, you can see the most affected places like Northridge, San Fernando, West Hollywood, and Sherman Oaks are in the darker red color, and you move away towards Malibu being in the orange. This is a very important thing to look at so that you can understand the intensity and just how far this earthquake was and how it affected such a large, vast area. Section 2, the damage done. Slide is going to be about fatalities and injuries. The original death toll was 57, but after including the heart attacks caused by the earthquake, the number was updated to 72. So in total, there were 72 fatalities that were related to the earthquake. While the heart attacks were included, the most common death was caused by head and chest injuries due to buildings collapsing, and of course there were a few car crashes and incidents on the freeway due to the freeway collapsing as well. Injuries-wise, there were 9,000 people who were injured, and mostly also due to buildings collapsing and car accidents. It's important to note that the injuries were very equal in gender. Aside from all the fatalities and injured, this earthquake caused 11,000 landslides. Most of these landslides were due to the earth shifting, causing the soil to shift, and then obviously collapse and fall. If you look towards one of these images, you can see that there's a house that fell off of the edge of a hill. Of course, it wasn't originally the edge of a hill, but all of the soil just completely quit and collapsed. Not only were there landslides, it also triggered about 110 fires. This all had to do with houses collapsing and gas lines being out and just resulting in literal chaos and a lot of damages. A lot of buildings collapsed during this earthquake, but the one that most people think about is the Northridge Meadows apartment complex. This building itself kind of crumbled upon itself, and it resulted in 16 of the 72 fatalities. Not only did that building collapse, though, there were 82,000 residential and commercial units that were completely destroyed after this earthquake, and it left a lot of people displaced and with nowhere to go. People, when thinking of this earthquake, the first thing that comes to mind is Cal State University, Northridge. The amount of destruction that was left on this campus was the loss of 5 buildings. Now, if you go to the CSUN campus, you'll see an area of remembrance for these buildings and how important they were to the campus. And you'll see that they have pieces of the foundation and like pieces of the wall, just so people can continue to see and understand just how damaged their campus was after this earthquake. They lost a lot of monumental and important buildings to them, like the west and east end of the university library. When do people think about CSUN? They think about the immense damage that was caused to the freeways. On a regular day, you see how much traffic there is on a regular freeway when the freeway is not collapsed. But imagine if 10 freeways were absolutely destroyed and they had to find ways for everyone to go around them. This directly impacted people who commute, emergency responses, and just caused this insane economic loss that it was hard to recover from. It didn't just affect the buildings though, it affected the people. 20 billion in damage costs and 40 billion in economic losses is a lot, but it left people so displaced with nowhere to go that they had to create long-term shelters for these people to have somewhere to sleep at night in any community building that was still up. But following the earthquake, they made it their plan to ensure that buildings were up to code so that these people would hopefully never have to go through this again, and that more homes would survive another tragic earthquake if we were ever to have to endure one. This section is about what we've learned, basically things that we've improved to ensure that next time we are better prepared. Seismic hazard mapping. Seismic hazard mapping is directed by the Department of Conservation to conduct a mandatory geological survey to identify earthquake-prone areas and prepare them for the worst-case scenarios. This is very important for people to know where they're moving, their houses that they're living in, and ensure that their families and themselves will be in a safe position if there was ever to be an emergency. This is very important. And if you look towards the map, you'll see that the places in red are the places where this is 100% mandatory, and you will need to be educated and understand where you're living. It's about Shake Alert LA, which is a U.S. geological survey that detects earthquakes soon enough to give the ability to send out an emergency notification to help people get to safety. This notification often resembles the one given for an Amber Alert, and this has become an important feature in communities that are earthquake prone because it does give people that few extra seconds to find safety. And it's also very important that you prepare in advance for what you will do in an earthquake, so that when you get this notification, you're fully prepared and aware of what you need to do. Following how important it is to know what to do during a drill is where the idea of the Great Shakeout Drill came from. This is a drill that is done yearly by schools and the community preparing for earthquakes. They use this time to teach every different type of individual, older people and walkers and wheelchair users, how important it is to know how to protect yourself in an earthquake. They also use this time to go through the worst case scenarios, people being injured, people needing help, faking injuries, to know that you know how to help somebody in a worst case scenario. This is very important and has helped the communities feel more at ease at the idea of an earthquake. Thank you for listening to my slideshow presentation about the Northridge earthquake of 1994.